Hey, what's up guys, here. My name is Jason and I have a few teammates who are going to teach you one of the courses called the scheduling algorithms. So what does scheduling algorithm means is it's very important in our computer system, and then you're able to maximize the CPU usage, you're able to maximize throughput and also reduce a lot with the response time. And we're going to talk about how the system works and at the same time to teach you some of the tutorial of course. And why not we just start the lesson now?
Good day to everyone. Today we are here to discuss about the processing scheduling algorithm. This is one of the chapter of the process scheduling algorithm. There are 6 types of processing scheduling algorithm, which are first come first serve (FCFS), and the shortest job next (SJN), and then the shortest remaining time round robin, and multi-level queue, and priority scheduling. Today I will here to discuss about the first 2 algorithms, which is the first come first serve and the shortest job next. Okay, let's just proceed to the first example, which is the first come first serve. And this is a non-predictive algorithm, and the job is handled based on the arrival time, and it's using the concept of earlier job arrive, earlier job serve. It's a simple algorithm based on using the FIFO, first in first out quick. Okay, let's proceed to the one of the example questions. On here, we can see that the process and the CPU time, and we're using this example to calculate its average waiting time and turnaround time. Okay, what is waiting time? It's the amount of process waiting in the ready state, and about the turnaround time is the amount of time to execute process from existing to until the terminate. Okay, the formula for waiting time is listed as the GPU time minus the arrival time, and then the turnaround time is completion time to minus the arrival time. Based on this, with this example, we calculate the average of the waiting time, which is using the GPU time minus the arrival time, which is as this example, arrival time is equal to 0. So we get 0 plus 50 plus 70 divided by 3, we can get the average waiting time. And about the turnaround time is also the same, which is sum out total the turnaround time and divide by 3, which and can get the result. Okay, let's proceed to another example of the processing scheduling algorithm, which is the shorter job next, simplified as SJN. This algorithm is a job handled based on the length of the GPU time. It's all using the concept of shortest GPU time or execute first. From this as another example of the question, you can see that job A has 5 GPU cycle, job B has 2, job C has 6, and job D has 4. So we arrange it in the timeline from the shortest GPU to execute first. So you can see here the job B, which has the shortest GPU time, will execute first, and then until the another one is the job D, which has the 4 GPU cycle, and we arrange it from the smallest to the biggest in this timeline. And then, same as the previous example, we're using it to calculate the waiting time and turnaround time and average it.
The round-robin algorithm is used in interactive system. It employs time sharing where the CPU time is shared equally among processors, giving every job an equal time slot or time quantum. If the job is not completed within the assigned time quantum, the job will be interrupted and proceed with the next job. And next, the time quantum size is crucial because it will affect the system performance and efficiency. The round-robin algorithm is a preemptive algorithm, as the scheduler will force the job out of the CPU once the time slot assigned to the job is expired. The overall process of the round-robin algorithm: first, the job is placed in ready queue. Next, the process scheduler selects the first job. It sets timer to the time quantum that have been assigned to the job and allocates the CPU to it. And the scheduler will let the job runs until the timer expires. 2 possible cases are going to happen. If the job CPU cycle is larger than the time quantum assigned to it, the job couldn't be finished completely within the time, so the job will be preempted and placed at the end of the ready queue. Its information saved in PCB and the next job will be proceed. For case 2, if the job CPU cycle is less than the time quantum, the job can be finished and the allocated resources is released, and next job proceed. Let's take a look onto this round robin example. There are 4 jobs over here, each with different CPU cycle and different arrival time, but all of them have the same time slot of 4 milliseconds. First, job A will be executed first because it arrived first. After 4 milliseconds, job A is preempted even though it hasn't been completed, and job B continues. After another 4 milliseconds, job C continues and followed by job D. The job that hasn't been completed will take turn into execution with maximum time slot of 4 milliseconds until they run completely. And below is the average turnaround time required to complete the process. In multiple level feedback queue, a process can move between the various queues with applied de-aging method. The multiple feedback queue schedule is defined by a few parameters, such as the number of queues, the scheduling algorithms for each queue, the method used to determine when to upgrade a process or demote a process, and the method used to determine which queue a process will enter and need service. This is how the scheduling works. First, a new job enters the queue 0 with first come first serve algorithm. When it gains CPU, the job will receive 8 milliseconds. If it does not finish in 8 milliseconds, the job will move to the next queue. The job will enter the queue 1 with first come first serve algorithm and receive 16 additional milliseconds. If it does not finish in that 16 milliseconds, it will be preempted and moved to the queue 2 with first come first serve algorithm until the job is finished.
Hey, what's up guys, back to another video. My name is Jason and you can see I just won the best project award. Yeah, just the past few weeks during my capstone project. Yeah, I'm so proud of it. So let's get back to the topic. So basically today I'm going to talk about priority scheduling and the shortest remaining time scheduling algorithm. So both of these algorithms are very powerful for our nowadays computing system. So let's get started. So what is priority scheduling? Priority scheduling is a scheduling that is non-preemptive, which cannot be interrupted, has high priority, process come first, and yeah, doesn't interrupt until the job finish. So basically, if there's 2 jobs comes together at once, so we'll pick using first come first serve to see who is coming at first and we serve them. So let's get into an example. So basically, I have a 5 different example process, and then each of them has different CPU cycle, and all of them also have different priorities. So let us arrange it into accordance, which is from the highest priority to the lowest priority. So this is from the highest to the lowest. And then once we arrange it, you can see that the CPU cycle and the waiting time and the turnaround time is already been calculated. So once it's calculated, you can actually estimate the average waiting time, which is about 3.6, and the average turnaround time is about 3.8, which is a very good value we can see over there, and it's quite short. So and also the fact is that you require memory requirement, it needs some numbers and types of peripheral devices, and also the total CPU times will be a fact. And most importantly, the amount of total time spent in the system, which is called the aging, is very crucial for computing system too, in order to prevent any delay in the inner system occurrence. So let's get to the next topic, which is the shortest remaining time, SRT. SRT is quite famous, in many computing systems. So SRT is sort of like a SJN, it's like a shortest job next, but it's preemptive version because it can be interrupt. And then if it's interrupt, if they have a new job coming at a shorter time, which means there will be arrival time. You see that? It's arrival time, there's a new stuff. So basically here we have 4 processors, we have different CPU cycle, and then if with different arrival time. So you can see that when we transform into a sort of a timeline chart over here, you can see the job A actually stopped at the very first because the process B already came at the very first second, so that's why it stopped. And C comes again at a second, which is second. This one will stop because C have the lower CPU cycle. We've done it first, and then continue to the part B, and also continue to the part D because D is presumably have lower than 6, which is allow him to undergo the process which have been interrupt over here. And last but not least, you allow A to finish the process at the end. So the average turnaround time is about 6.25, and still the priority strategy are still better in this case. Yeah. So thank you for watching through this tutorial. Hey, welcome back again. So basically, I believe you have learned all of types of the scheduling algorithms. We have tutorials and we have examples. And I hope that you can actually hands-on with the tutorial by yourself and learn it by yourself. And last but not least, I gotta wish you best of luck with your final exam. Thank you.